All right, Algebra 1 students, welcome to your 2.1 notes, solving one-step equations. In solving one-step equations, we are going to take a look at equivalent equations that have the same solution. Okay, so addition property of equality. Adding the same to each side of the equation produces an equivalent equation. And so what it says here in our notes are, for any real numbers a, b, and c, if a equals b, then a plus c is equal to b plus c. Okay, so what happens here is basically if we do the exact same thing to both sides of the equation, which they've done here for our example, we're going to end up with the same thing. So we can use it to solve some equations. So in our example, all right, so what we're going to do in our example is we're going to add 7 to each side of the equation. And so when we do that, what happens is we end up isolating the x. All right, so our equation now looks like this. X equals 18. Basically what we've done, we've just added 7 to each side of the equation. That causes the 7s right here to cancel each other out. And then we do have to do anything we do to one side of the equation, we have to do it to the other side of the equation. So we end up with x equals 18. All right, the subtraction property of equality. Subtracting the same to each side of an equation produces an equivalent equation. It's basically the same thing we just did, except the other way around. So in this one, we're going to subtract 7 from each side. All right, and so what we end up with here is x equals 4. All right, so let's take a look at some more examples of this. All right, so here in number 1, we've got x plus 11 equals 8. So all we have to do is subtract 11 from each side, and that's all we have to do here. So we're going to end up with x equals -3. All right. Number 2, we have -5 equals x plus 8. So in this case, we're going to subtract 8 from each side of the equation. All right. X is going to be over here by itself, and it doesn't really matter which side of the equal sign you put x. I kind of like to write it like this. And then we're going to end up with x equals -13. Number 3, x minus 7 equals 8. All right, so in this case, we're going to do, pretty much, if you guys are getting the hang of this, we're pretty much going to do the opposite of whatever that guy right there is. All right, that's what we've been doing. So I think a lot of you guys have figured out we're adding 7 to each side on that one. X is going to be equal to 15. All right, in this one, number 4, let's add 5 to each side. All right, x is going to be equal to -5. All right. All right, now we're going to take a look at the multiplication property of equality. And multiplying each side of an equation by the same non-zero number produces an equivalent equation. Okay, so for any real numbers, a, b, and c, if a equals b, then a times c is equal to b times c. For those of you who might not be able to read that very well, that right there is multiplication. So we could also write that So basically what we're doing here is we're going to take the multiplicative inverse. All right, so for our example, we have x divided by 3 equals 2. All right, and so what we're trying to do is we're trying to multiply something on this side of the equation. Didn't want that to move. We want to multiply something on this side of the equation to get that x isolated. So we're going to use our ability to multiply by the multiplicative inverse. So here's what we're going to do. If we multiply 3 times x over 3, all right, which already exists, we need to multiply 3 on the other side of the equation too. So Let's multiply 3 over here. 2's already sitting there. All right. So basically what this property of equality allows us to do is isolate that x. So those of us who like to think about it by canceling things out, this is also the same as 3 over 1. Okay. And now we have x equals 6. All right. So that's what we're up to there. All right, the division property of equality, very similar to the multiplication property of equality. All right, so if we divide the same thing on each side of the equation, you still have the same equation. So it says for any real numbers, a, b, and c, if a equals b, then a over c equals b over c. All right, so what we're going to do with our example here is we're going to divide both sides by 5, because again, we're trying to get that x all by itself. All right, when we do that over here, we're going to end up with x is equal to 4. And now you have it. And here we go, we're going to work on some examples here. So let's see what happens on number 5. We've got 3x equals 12. Again, what we want to do is we want to figure out how to isolate this x right here, get that puppy all by itself. In this particular case, all we need to do is divide each side of the equation by 3. All right, that causes these two 3's to cancel out. We're left with x is equal to 4 when we reduce that side of the equation. For number 6, we have 27 equals -9. All right, so if we remember our multiplicative inverse, what we need to do on this is we actually need to divide by a negative number. So that we'll leave with our x as a positive value. So, you know, it's basically the rule, if you divide by a negative, if you've got a negative divided by a negative, you get a positive, okay? So we're simply going to take a -9 from each side. So in this case, we're going to end up with a -3. All right, x is equal to -3. Number 7. Okay, here we're going to do our multiplicative inverse. All right, we're trying to figure out how to get this x right here all by itself. By the way, a lot of times in Algebra 1, students start to freak out when they see fractions, okay? So just so you know, you guys are going to be exposed to fractions all semester. Get used to them, get comfortable with them, it's going to happen, all right? So don't freak out when you see fractions, just understand what you're supposed to do. So we have a fraction with x over 7. All we have to do is multiply both sides times 7. So it should look something like this. 3 times 7. Okay. Those 7's cancel out. Okay, then we're left with an x all by itself on one side of the equation. We know that 3 times 7 is equal to 21. We're done with number 7. All right, number 8. We're going to multiply each side by 4. I think you guys are quite quickly getting the hang of this. So, oops. Keep moving things. -8 times 4 is equal to x over 4 times 4. Okay? On that one, the 4's cancel out. All right, we're left with x isolated by itself. And we have a -32. Because 8 times 4 is 32, we've got the negative sitting there. So that's your answer for number 8. All right, you guys could probably figure out that we are doing problems that are going to undo each other. All right, that's what we've been working on for this 2.1 section. So we're going to actually take a look at why that's the case. Inverse operations undo operations. We undo operations in the reverse order of the operations. So the inverse of addition is subtraction, and the inverse of subtraction is addition. I think you guys probably figured that out. The inverse of multiplication is division, and the inverse of division is multiplication. You guys probably figured that out as well from the previous examples that we've been doing. And so let's go ahead and take a look at a couple of practical applications of what we're up to here. A train is 100 miles away from the station. It is approaching the station at 40 miles per hour. How long will it take the train to arrive at the station? All right, folks, so we have a little bit of a simple or a basic physics problem going on here, and we need to understand one of the physics formulas, and that is that distance, I want to be writing, distance equals rate times time. All right, and in this particular problem, we are looking for a variable, and when we see it say, how long will it take for the train to arrive at the station? That tells us that the variable we're trying to figure out is time. All right, so we know a couple of things in this equation. We know that we're 100 miles away. Okay. We also know that that the train is approaching the station at 40 miles per hour. Okay. All right. Some of you have seen that. That miles per hour before, but so we're gonna just kind of move on from there. Here we go. We're gonna set it up like this. 100 is going to be equal to the rate, 40 miles an hour, times time. All right, and now all of a sudden, this looks exactly like the operations that we've been working on. All we need to do is the inverse of it. So we have the inverse of multiplication. We just need to do division. Let's divide both sides by 40. All right? And we're going to have t equal to 2.5 hours. All right? Let's take a look at our second example. Netflix offers streaming video for $8 a month. Jake's grandma gives him $50 a month for his birthday. How many months can Jake afford Netflix if he only uses his birthday money from his grandma? Okay, so we're going to do another one where we've got a variable, and our variable in this case is going to be time again because it says how many months. All right, except for in this problem, time is going to be in months. All right, so time is going to be in months. Okay, so grandma gives him $50, all right, and it takes $8 a month to get Netflix. There's our equation set up, all right, so we've got 8 months times time, all right, and we've got $50 that his grandmother gave him. In fact, I'm going to go ahead and erase this because this might confuse some of you. Don't worry about what I had written there. Pay no attention to the man behind the curtain. Okay, what do we do from here? Well, we know we've been doing these problems this entire video. We're going to divide both sides by 8. Okay, we're going to end up with 6 1/4 months. Okay, and since Netflix usually doesn't give you streaming for just a couple of weeks, we can finish our problem by saying Jake can have 6 months worth of Netflix video. And that concludes our notes for today. Come to class ready to work. We will see you soon.